right, good morning, everyone. Just a quick reminder as to how all these points are going to work for your pre-AP tests. What you just got done taking yesterday was the FRQ portion of the pre-test. That's going to be worth 50 test points, 50 points. The next part that's coming up is the multiple choice portion, and that's what we're going to be working towards. That'll be split into 2 days, Wednesday and Thursday. And the reason why is because all next week we have EOCs going on, so EOCs will be like from 8:30 to 10:30, 11-ish. Some days are longer than others, but Wednesday and Thursday will be the shortest EOCs, so it allows us to have a full 30 minutes, at least 30 minutes in class. So we'll do multiple choice 1 through 8 on Wednesday, and then we'll do multiple choice 9 through 16 on Thursday. There's going to be some overlap in topics, but mainly I'm going to keep first part to be first semester material, and then second 9 through 16 to be second semester material, just to kind of give you some area of focus. But there's going to be some overlap. I'm not going to be able to avoid that, but at least you have some idea as to what to focus on each day. That'll be worth 50 points total. So 50 plus 50, that's 100 points. And then finally, the other 100 points is going to come from the notes and assignment that you guys will be turning in 3 separate batches. So the first batch coming up is tonight. Assignments 1 through 5 due tonight in teams. I know there's a limit in the number of photos that can be submitted in teams assignments. So if you want to take 2 pages per photo, that's perfectly fine. The assignment is going to close at midnight. So if you don't get it in by midnight, then you can send it to me through email. You'll still get an A for the assignment, but if you can get it in time, you'll get full credit. So, all right, and all this is going to go in as one test, one grade, 200-point test grade in Infinite Campus. Okay, so we have 1 grade remaining, and this is it. Okay, any questions? Okay. Just quickly over the calendar as well. We're going to be spending these next few days just going over specific multiple choice topics. I'm going to go in order. So today I want to focus on limits, continuity, derivatives. I don't think we'll be able to get through the entire worksheet that I want to get through, but it's going to be every multiple choice worksheet is going to be 4 pages. I'm going to just be picking out problems that I want to do in class, and then whatever we don't do in class is going to be your homework. So there's no separate document. It's all within that worksheet. So every homework assignment is 4 pages. So there's 4 pages worth of multiple choice problems here, and whatever we don't finish is your homework. Okay. So tomorrow, I'd like to focus on the second half of derivatives, or first semester, which is related rates, curve sketching, and a lot of the calculator work with curve sketching is going to be, I want to be able to practice those types of problems on Thursday. Friday, I want to focus on second semester topics like integrals, like use substitution, second theorem of calculus, area, volume, solving differential equations. But I think a lot of those topics we've kind of seen in bits and pieces with FRQs. So I think we're pretty familiar with those, but I want to kind of show you what they can look like in the multiple choice format. Monday, Tuesday will be cut short. So we'll just spend these days kind of finishing up any problems that we need to do, maybe go over problems that you want to go over, or I can pick out some more problems for the worksheet to finish up, and also maybe hit on some miscellaneous topics as well. And then Wednesday, Thursday will be your multiple choice test. Friday, Monday, just some last minute reminders. And then your AP exam is going to be not next Tuesday, but the following Tuesday. So coming up less than 2 weeks. So if If you're still considering wanting to take that June exam, you need to reach out to Ms. White, because otherwise, if you don't say anything, then you're just going to be locked into this May 4th date. The final assignment is going to be due that Friday, May 7th, and I'm going to try to finish up all the grading by this weekend so that by that Monday I can have all the grades in the grade book. That's my goal. Okay, any questions with our calendar? Okay, so there's two things that you guys picked up at the front of the classroom. There's the 4-page packet, and there's also this formula sheet. And if you're at home, then the formula sheet is attached to the back of the packet that you printed out. So I want to talk about this formula sheet here. This is kind of the accumulation of the formula sheet from FRQ along with the notes that we've been kind of going through as we were reviewing different topics. So I think this is a bit of a daunting task because we've been doing open notes this entire year, and all of a sudden for the AP exam, you'll be doing it without notes, without formulas. And so what I wanted to do was to create what I think is the most important information to commit to memory. And there's more to it than 2 pages, but I just want to just get it down 2 pages so that you can just focus your attention on these 2 pages. Maybe I'll try to do a more extensive, comprehensive rule sheet that includes the rules that are less common. But I think this will be a good goal for us. If we can, over this next few weeks, as you're working through the worksheet, as you're working through your multiple choice packet, that you're constantly referring to this formula sheet. I think you already know a lot of this already, but continue to look over this, get comfortable with it, because if you can memorize, if you can commit these formulas and concepts to memory, then I think that will account for like 90–95% of what could show up on the AP exam. I mean, there may be some obscure ones, but let's focus on the most common ones. Okay. So let me just want to kind of go through these real quick in terms of the concepts here. The first is limits, evaluating limits algebraically. I have some steps spelled out. We have a different set of approach for limits approaching infinity, right? We compare degrees, we don't plug values in. So we'll do a problem like that on today's worksheet. And L'Hopital's rule, I think this is a really good one for us to use, because this is kind of like a rule that can handle a large part, or just a wide variety of limit problems. Basically, most everything can be handled using L'Hopital's rule. So we want to make sure that we're really good with this. There are other rules, but they're kind of more specific to handle, very specific problems. But L'Hopital's rule can just handle a wide range. So let's just see if we can get really good with L'Hopital's rule. Continuity conditions. This is the way to determine whether a function is continuous or not. We'll practice one of these problems. It's important for us to commit this to memory and to know that this is something we may need to apply on the AP exam. IVT. It's just looking to see if whatever my target point is, do I have a point below it and a point above it? If I do, and if the graph is continuous, it has to go through that point. And then I also demonstrated how you would justify your answer using IVT in this particular form. So I put out an example justification for IVT. These are the most common derivative rules. There's more than 8, but if you can commit these 8 to memory, chances are it's possible that these are the only 8 that show up on the AP exam. So we definitely need to know these. Okay. There's more than 4 trig, but these are the ones that show up the most often. Okay. Product rule, quotient rule, chain rule. You guys know those. L'Hopital's rule, I wrote that down again. Linear approximation, we've been doing that quite a bit recently. You saw that on the previous FRQ as well. Mean value theorem, EVT, Rolle's theorem, we've seen these quite a lot as well. These tend to show up more often on the free response, but it could also show up on multiple choice. Integral rules, there's more than 7, but these are the most important ones, right? So power rule, e to the u, natural log, arctangent, sine, and cosine. Okay. Below, I included some common area formulas that we definitely need to know. I did not include volume formulas. So volume of a sphere, volume of a cone, surface area of a sphere, those they will give you. Okay, so if they're going to ask you a related rates problem about a sphere, they'll give you the formula. But we need to know the area for these basic area formulas. We do need to know. Okay. The back here, I put a lot of variations of first theorem. Final position equals initial plus displacement. A lot of these variations, depending on the problem, we may need to apply one of these variations to our as a rule for our problem. Second theorem, we'll cover this on Friday. Average value theorem. I'll show how these can show up in multiple choice form. Antiderivative word problem formula. Total amount equals initial plus amount added minus amount removed. We use this formula when we're working through a problem like, people leaving and entering the amusement park, or sand being added to the beach and being pulled away by the tide, right? So these are good formulas to know, especially with antiderivative word problems. They show up quite a bit. Particle motion formulas, I indicated all these, basically is PVA, relationship between velocity, acceleration, increasing, decreasing speed. So these are all really good ones to know. Area and volume. So top minus bottom for area, or right minus left. This method, drawing our one radius if there's no gap between our shaded region and our axis of revolution. Washer method. Okay. Cross-section formulas. There's quite a bit here, but from AP exams that I've seen recently, if they ask you for cross-section, they tend to just use the square. That's the tendency. That's the one that I see the most. They tend not to do the more obscure ones. But I mean, if you can memorize these, then you can have peace of mind. But chances are, if you see cross-section, it'll probably be a square. Derivative of inverse at a point. This is where we create a chart and we kind of move our way around the chart. It's kind of like a very, very specific type of problem. I'll put this maybe on the Monday review sheet. Log differentiation. This is more rare, but it does show up. I've seen it in the past, so if I have time, I'll go over an example so you know what to do with this type of problem on maybe a few days before the AP exam. Natural log properties, these are good to know as well. We want to apply natural log expand terms, especially if you're trying to find a derivative and you want to find a derivative of separate terms rather than a messy large problem. So we want to make sure we know how to expand properly. Explore expansion before taking derivatives, especially if you have natural log problem. Second derivative test, this is just saying that if my graph is concave up, I'm expecting relative minimum. If my graph is concave down, I expect relative max. So we'll go, maybe I'll pick out a problem or two when we get to one of our miscellaneous days. Okay, so yeah, so your goal hopefully is be able to commit most of this to memory by the Tuesday of your AP exam, and you should feel pretty confident that most everything you see you'll be able to access, or you'll be able to apply. All right, let's go to our worksheet. So on this packet, I'm just focusing on the initial. These are, I wrote down all the big topics that we're going to try to get to, but we're just going to be focusing on limits and continuity, L'Hopital's rule, derivatives, slope concepts, and implicit. I don't think we may not get to all these derivative terms, but we'll at least get through limits and L'Hopital's rule. Okay, so we have the graph of function f is shown, at which value of x is our function continuous but not differentiable. So we want the graph to be connected, but not a smooth curve, not part of a smooth curve. Okay, so where is the graph continuous but not differentiable? At A, yeah. So if you look at A here, we see there's a sharp turn there. It's obviously continuous because there's no breaks there, but it is not differentiable, right? Okay, so while we're on this graph, I'm going to extend this problem a little bit more just for we can explore limits and continuity just a little bit further. So if you guys can write this down here. I'll call this 1b. Where does the limit exist but not continuous? B, okay. Where? Good, so B is the right answer, but let me just explore that a little bit more as to why that's the case for B and not the case for D. So if you look at D for a moment, the reason why the limit does not exist at D is because if I were to pick points on either side of D, and if I were to draw an arrow along the path of the graph towards D, I see my arrows are not consistent, right? One arrow is headed towards the direction, another arrow is going to another direction. These are not headed towards the same destination. So that's when we know the limit doesn't exist. But if you look at point B, I can pick points on either side of B, and if I draw an arrow towards the path of the graph, I see my arrows are headed towards the same y value, right? Even though the point is not defined there, the arrows are moving to the same location. They're pointing towards each other, right? And the fact that they're pointing towards each other indicates that the limit does exist. All right, any questions there? All right, let's look at number 2. Number 2, notice that you see there's a piecewise function here. So anytime we see a piecewise function, and if your answer choices mention anything about continuity or discontinuity, I'm just going to go directly to my continuity conditions. Continuity conditions is a way for, it gives me a nice structure to work through a problem. And even if not everything is needed, it kind of helps me get a sense as to what's going on, right? So I'm going to just go through continuity conditions and I'll be able to get a clear picture as to what's happening. And once I get a clear picture, I can decide which of my answer choices is going to stand. So let me go through continuity conditions. Continuity condition says if I want to determine if a function is continuous at a point, first thing I'm going to do is, does the point exist? Okay. Second thing, does the limit exist? And sometimes we got to do one-side limit, but you only do one-side limit if you see a piecewise function involving inequalities. If you see less than or greater than in your inequality, then you know you have two separate functions that are defined on either side of a target, and we got to do one-side limit because we got to evaluate two separate expressions. But for number 2, we're going to see that we don't see any inequalities, so all we need is one limit statement to handle an expression. Okay, so the point exists, the limit exists, but then does a point live where the limit exists? So when we get down to the third condition, we're just comparing the results of the first two and seeing if those two results are in agreement. If they are in agreement, all 3 conditions pass, our function is continuous. If they're not in agreement, the function is not continuous, that means there's a hole in the graph. Okay, but let's go through each of the conditions here. You see that the point in question, or the center of our problem, is at x equals 2, so that's our c value. Okay, so first condition, f of c is defined, f of 2, we see is defined there. 7. Second condition, does the limit exist? We don't have to go through one side limit because we only have one connected parts of graph. Notice that the second